Good morning, everyone. I am your tutor for today. So I hope you guys are in good health. Uh, at this moment, there are only 7 of you. So I think while waiting for your other friends to join, you guys can start working on questions number 1. I saw that the tutorial questions is already up in the ULearn. Okay, so you guys can try by yourself how to do questions number 1. Before that, I will try to brief a bit about the questions number 1. Can someone confirm whether you guys can hear my voice and also my slide? Anyone? Okay, thank you. Okay. So for today's tutorial, we will cover questions from the second part of chapter 4. Okay. So basically for questions number 1, you can see that it's already given the force is actually 450 Newton, which is here. And then the questions want us to find the magnitude, with condition that the moment has to be about the x-axis. So that means to find moment about an axis, we have to use formula. This one. Hello, can you guys hear me? Okay, can you guys see the? Can anyone confirm for me? Hello. Okay. Okay. So I will continue with the uh, uh briefing. So basically, for questions number one, it wants us to find the magnitude of the moment about the axis. So when you have a moment about an axis, you guys have to use this formula. So in this case, there are three values that you guys have to find. You a unit vector at x-axis, and then you guys have to find the r vector and also f vector. So using this one, please try doing this on your own within 5 to 10 minutes. We will discuss this after the time limit. Okay, we will discuss the solution to the solutions to the questions together. So basically for questions number 1, we have to use this formula as I mentioned earlier. So basically these three items, U vector, R vector and also F vector, we don't have the value. So we have to find these three values first before we can find the moment. So in this case, so we will find unit vector about the x-axis. Why unit vector about x-axis? This is because it mentioned specifically in the questions. You can see in the questions here about the x-axis. So usually when other questions, they will specify like find the moment about AB axis, CD axis, OA axis, where they will mention 2 points along the axis. However, for questions number 1, you can see it only mentioned about the x-axis. So that means you guys have to find the unit vector along the x-axis. So in this case, unit vector for along the x-axis is j. Because if x-axis is I'm sorry, it's actually I. If vector about x-axis, it should be I. If the questions ask you to be the questions about the y-axis, then your unit vector should be j. If the questions ask you to find the moment about the z-axis, then you guys have to use k. So in this case, since it mentioned about the x-axis, so unit vector about the x-axis is I. So only I. Okay. So now we settle with the unit vector about the x-axis, and now we have to find the r vector. So for the r vector, it can be from any point along the line of the x-axis to the point B, the coordinate that we know. Okay, so in this case, the most obvious coordinate along the x-axis is A. So we will have to use, so we can take this point to be our RAB. Okay. Okay, so you guys have to know the coordinate first. So A is 0, 0, 0, and B is negative 0.15. I directly convert from millimeter to meter. 0.3, 0.1. So this is the coordinate for B. So when we have these two coordinates, then we can find the r vector about from A to B. So you guys will get r vector AB to be negative 0.15 I plus 0.3 J plus 0.1 K. Okay, so now we already find this one, so we have to find the vector for f. So it's already given here. F value is equal to 450 Newton. So for formula to find a vector is equal to F vector equal to F times with U vector. Okay. So as you can see, usually in our previous questions, we can use like coordinate to find the value of the unit vector of the force. But in this case, we don't actually have the coordinate. So this is the formula we used previously, but we also have another formula to calculate the unit vector of the force, which is cos alpha plus cos beta j plus cos gamma k. Okay. So since in the questions it's already given the angle of the force to the respective axis, so we can use this formula. So you guys, so F is 450. Then so cos alpha is here because this one force the angle is between the force line and also the x-axis line, because it's facing the negative side of the axis, so it should be negative cos 60 I, and then j for the cos beta is here, angle between here and here, so that will be another, because it's in positive y-axis, so it should be positive cos 60 degree j. And then for the gamma is between the angle between the force and also the z-axis, 45. It's plus because it's on the positive side of the z-axis. So in this case, you guys will get negative 225 I plus 225j plus 318.2k. Okay, so now we already have all three components here. So we can now find the moment about the x-axis. So okay, so there will be 3 rows here. So the first row should be for the unit vector about the x-axis. So you guys can refer here. So the vector for the unit vector for about the x-axis is I. So I is this actually equal to 1. So for the j and k part, you guys can just put 0, 0. And then the second row should be the r vector along the AB point. So we take from here. So it will be 0.15 negative 0.15, 0.3, 0.1. And then the third row would be this part. Negative 2 to 5, 2 to 5, then 3, 1.2. Okay. So you guys solve this matrix. So it will be something like this. And this one should be minus because in matrix for the when you try to multiply for the j part, the j will always have negative. So this one we settle. I'm sorry with my explanation just now. I'm sorry. So basically, the first part we settle for the I part first. So negative 0.15 you times with 2 to 5, and then you minus this one 0.3 times negative I'm sorry, I apologize again. I'm sorry, okay. Let me redo this again. Actually, so we have to multiply for I part. So it's basically 0.3 times with 318.2, and then you minus with 0.1 times with 2 to 5. Okay. So this is the correct way. Okay. So you guys have to settle for the j part and k part also, but since this one is 0 and 0, so you guys no need so the value will be actually equal to 0, so it's okay not to settle that part. So when you guys settle for this part, you guys would get the answer 72.96 Newton meter. Okay, so this is the answer for questions number 1. So do you guys have any problem with questions number 1? Or do you guys have any or if you guys don't understand, you guys can ask me. Are you guys clear with questions number 1? Okay, so if you guys clear, we can proceed to questions number 2. Okay, so this is questions number 2. So basically for questions number 2, it wants us to find the magnitude of force F. Since and then the resultant couple moment would be 100 Newton meter clockwise. So that means because there are several moments here, so what you guys have to do is, and we have several moments, we have several forces here, and the direction also not consistent. So what you guys have to do is, first one is break down the forces. And then find F using the formula. This is the resultant couple moment equal to sum of the moments about point. Let's say this here is about point O. Okay. So since the resultant couple moment is 100 Newton, so you guys can use this to find the unknown F. Okay. So you guys can take 10 minutes to try to solve this problem on your own, and after 10 minutes we will discuss this together. Okay, so it has been 10 minutes. So if anyone else got the answer, you guys can share in the chat. It is okay to have wrong answer, because when you have wrong answer, you remember better. Okay. Okay, so let us discuss questions to A first. So as you can see, we have several forces here at different angle. So then we have to break the forces. There are actually two ways to break down the forces. Either you guys break down it horizontally and vertically, or you guys can break the forces tangentially and radially. Okay, so for today's tutorial, I will show step to break down the forces we use here, tangentially and also radially, because it's one step shorter compared to the horizontally and also vertically. Okay, so basically, we have to break down the forces first. So we will satisfy this part first, the top part. So this is radial to the so this should be 300 cos theta, and this direction of forces that tangent to this line 300 cos theta, and the one that radial to the point O, this one should be 300 sin theta. So then we down bottom here. given that radial to the point O should be 300 sine 300 sine theta, and here it should be 300 cos theta. Okay. Now we have, as you can see, it's already given angle here. Between this line and also this line is already given angle, so we can just break down these forces that radial to this line. And then tangent to this line. Okay, so now the angle given is only up until here 15 degree. So we don't know the angle here, but as you can see, this angle and also, this line actually is continuous line from here, and also this line actually parallel to this line here, so that means this should be 30 degree. So in total it should be 45. So now we have the angle, so now we can solve the breakdown forces. So this one should be F sine 45 degree, and this one should be F cos 45 degree. Okay, now we have to break down force here. So as you can see, we already have a line here, so you guys can just continue the line so that we can have force, we can have radial force to the point O. Then here, tangent to the line. So as you can see, we don't know what's the angle here, so we have to find it. Since this line is continuous from this line, and you can see also this line is actually parallel to this line, so if 90 minus 30, so this one should be 60 degree, so that means this also should be 60 degree. Now we have 60, 15 degree, so this is actually 90 degree. So to get this, it would be 90 minus 15 minus 60, so you guys will get 50 degree here. Okay. Now we already know the angle, so we can solve the force here. So the force here would be F cos 15, and here would be F sine 15. Okay, so now we already break down all the forces. So the next step would be we have to find the total moment, which force times with distance. Okay. Okay, earlier, so we have resultant moment equal to sum of force time distance. Okay. Okay. Okay, so there are actually many forces here, but which forces actually we can put into our calculation? So you guys have to choose carefully. So first, the one with the one that radial that pass through the point O here, like this one, and this force also pass through point O, and this force also pass through point O, and this force also pass through point O. So all forces that pass through point O actually have no moment. So you guys don't put this into the calculations. So I have to write it. So all these four forces, guys have to remember, don't put into the calculations. I will put down the note here. Okay. So now you guys know which forces that we should not take into our calculations. So now, this force, this force, this force. Okay, this force. So the blue color is actually the force that we want to put into our moment calculations. So okay. So we said that the resultant couple moment 100 Newton meter clockwise. So since it's clockwise, we have to put it like this. And then you know that the resultant moment value is 100. So put here. And then now you guys have to sum all the blue forces. So okay, since this one is clockwise, so we also have to define the rotation of the disc clockwise. Okay. So now, yes, no,
Miss,
yes.
why is the 100 Newton meter is positive, not negative?
Oh, because it mentioned in the questions, you see, resultant couple moment is 100 Newton meter clockwise. It's actually already defined the direction for you.
So not negative 100 for the clockwise.
No. So since it mentioned 100 is clockwise, clockwise should be, so clockwise should be 100 Newton positive.
Okay, thank you, Miss.
But if you define the direction to be anti-clockwise, then the value should be negative 100. So it depends on how you define the direction. So if you define the direction to be anti-clockwise, then the value should be negative 100. If you define the direction to be clockwise, it should be positive 100 because this is stated in the question. Are you clear for that part? Actually,
Miss.
actually you can use whichever direction that you are comfortable with because at the end the result should be the same. Okay. So, but in this case, because it's already mentioned clockwise positive, so I will just use the clockwise to be positive. Okay. Miss, can you explain the point you mark with star again? Oh, okay. So actually we already break down the forces that tangent to the line and also radial to the line, but not all forces you can take into the equation, because this is the reason. So if the forces pass through the point O, no moment produced at this point. So that means there's no meaning you put into the equations, because there's no moment, the value is zero. So you guys don't have to put this one into the calculation, because as you can see, it's actually pass through point, the center point here, the rotation center. Okay, because to calculate moment, you guys have to have distance. So since these forces actually pass through point O, you guys don't have any distance, so the distance is zero. So for example, for this part, 300 sine theta, you guys times with zero, so it's actually zero, no moment. So this is the explanation, because since the forces pass through point O, so no moment produced at this point. So you guys don't have to put this value into the calculation. Are we clear for that part? Okay. Okay. So now, okay. Since you already define the direction is clockwise, the moment direction is clockwise, so the value of the moment, resultant moment, is 100 Newton meter. So now we have to sum all these forces here. Okay. So 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 I take this point first. Okay. Since the first equations mentioned that the degree is 30 degree, so this value can just sub with 30 degree. Okay. Okay. So this one is 300 cos 30 degree times with the distance. So the distance is, radius is 300 millimeter. So if we directly convert into meter, it will be 0.3. Okay. Okay. And then we already settled this force, and now we take this force. Okay. This force should be negative, because as you can see, this is clockwise, and the force here is actually anti-clockwise, because it's opposite direction to the rotation of the disc. So negative should be negative f cos 15, and the radius, the distance is the radius, so 0.3. Okay, now you take this value. This one should be plus, because it's follow the direction clockwise. So 300 cos 30 times 0.3. Okay, and then we sum this force. This one also should be negative, because it's pointing this way, which is, if you imagine rotor impedance, wheel of fortune. Okay, so if you rotate the disc at this point, it will be anti-clockwise, so it's negative f sine 45, and the distance is the radius 0.3. So from here, you guys can actually solve. Should be So if you solve this, you guys will get about 111 Newton. So this is the answer for questions A. So do you guys clear up until this point? If you guys are not clear, you guys can ask me. Okay. So I assume you guys understand up until this point. So then I will proceed with 2B. Okay. So for 2B, the 2B, it mentioned that it actually changed the value of the forces. So the F is equal to 200 Newton. And then resultant moment now is 0, no longer 100 Newton meter. So with these two conditions, it wants us to find the value of theta. The theta which is here. So this one, you guys can just use the same formula up here and substitute the value. So in this case, so resultant moment is 0. So you guys can just directly copy from up here. 300 cos theta times 0.3 distance minus F is 200, so 200 cos 15 times 0.3 radius plus 300 cos theta times 0.3 minus 200 sine 45 times 0.3. Okay. So so if you guys solve this, you guys will get 180 cos theta minus 139, and then you guys can solve the theta. The theta is actually equal to 56.1 degree. Are we clear? If there is anything that you guys don't understand, you guys can ask. Okay. Okay, so if you guys don't have any questions, oh, so you just thought the counterclockwise was positive. No, it's actually clockwise is the positive because it mentioned in the questions. So that's why you guys have to highlight or take note on the keyword in the questions. So clockwise is, if the moment is clockwise, then the value should be positive 100. Okay. But if you guys define the moment direction to be anti-clockwise, then you guys have to change the value from 100 to negative 100 because it's opposite directions. So it should be indicated by using the negative sign. Okay. So if you guys have no problem with questions number 3 and number 2, so we will proceed to questions number 3. Okay. So this is the questions number 3. Oh, okay, sure. So this is question number 1. So do you have any questions for questions number 1? So Arif, do you have any questions for number 1? Okay. Alright. So if you're good, then we proceed to questions number 3. Okay. Alright. So for questions number 3, it's actually want us like to find. It says to replace the loading by an equivalent resultant force and couple moment acting at point O. So that means that you guys have to find the resultant force. And you guys also have to find the moment that acting at point O. Okay. So for this one, you guys can just use the same formula for moment, which is sum of force times distance. And for FR, you guys can use formula of the surface area to find forces at region. You guys have to divide the region and then you sum the forces. Okay, so please take 10 minutes to solve this problem and then we will discuss this together. Okay, so we will start discussing for questions number 3. So anyone else get the answer to the questions? If you do, you may share. So we will do questions number 3 together. Okay. So basically, for this kind of questions, we have to find the resultant force and also the moment acting at point O. So as you guys can see, in the diagram there, the shape is actually quite irregular. So you guys can actually break down the shape into something more familiar to all of you. Like in this case, we can break down the area to be triangle and also rectangular. Okay, so I divide the area to be into 3 parts. And then you can see the moment here is 5 kilonewton meter. So that means the limit up until here is actually 5 kilonewton meter. And from here until here is actually 8 kilonewton per meter. So this should be, so this is 5 and this is should be 3 kilo per meter. Okay. And then you guys have distance here 1.5 meter, here till here 0.75 meter, and here is 0.75 meter. Okay. Okay. So now we have to find the individual force according to the area first. So we will find 4 area here. The first area. Since all the forces are pointing downward, so we can just define our forces downward to be positive. So this one I label as force number 1, so equal to 1/2 times 3, the height here, times with 1.5 here. The distance here, 1.5. So you guys will get 2.25 kilonewton. Okay, and then we find the force for the second area here. I label this as force number 2. Okay, so the area is width times height, then guys put 5 here, 5 kilonewton meter, times with 1.5 plus 0.75. Then you guys will get the total to be 11.25 kilonewton. Okay, now we solve the third area here. The third force. So 1/2 times 5 times 0.75. Guys will get 1.875 kilonewton. Okay. So now we already get individual forces for each area. So since we already get that, then we can find the resultant force that requested by the questions. So in this case, the resultant force would be you guys just add up all the forces here. So 2.25 plus 11.25, 11.25 plus 1.875. Then you guys get 15.375 kilonewton. Okay. So now we already settled for resultant force, and now we have to find the moment acting at point O. So for moment acting at point O, as you guys know, moment at point O equal to sum of the forces times with the distance. So the forces here is the F1, F2, and then the distance. We don't have the distance for F1, F2, F3 yet. So we have to find example, here is x1, the distance here, and then this one is x2 we have to find, and here is x3 we have to find. Because it's at point O, the distance should be measured from the point O to the forces. Okay. So to find the distance, you guys can use the formula for the centroid. So for x1 equal to 1 over 3 times 1 over 5. So because it's triangle, so 1 over 3 times 1 over 5 is the total distance of the area from here to here. Okay, so you guys would get 0.5 meter. X2, you guys, x2 is the rectangular, so 1 over 2 times 1.5 plus 0.75. So you guys would get 1.125 meter. And then x3 is the triangle here, 1 over 3 times 0.75, the distance here. So it's equal to, sorry, because this one is from point O, so you guys have to add this point and also this point. So plus 1.5 plus 0.75, then you guys will get 2.5 meter. Okay. Okay. So now we already know the individual distance for each forces. Now we can use the formula. Okay. So I define clockwise to be positive because all the forces here pointing downward positive. So for easy calculation, I define the clockwise to be positive. So moment at point O is equal to so the first force is 2.25 here. You guys times with the distance here, 0.5, and plus force number 2 is 11.25 times with the x 1.125. Then you guys plus force F3 1.875 times with the distance of the x3 is 2.5. So you guys should get 18.47 kilonewton meter. Okay. Okay. Wait on. Y is a triangle 1/3. Okay. So that's actually the formula. That's the formula for the triangle, to how to find the distance from how to find the distance. Okay, this is actually the formula, so you guys have to remember the formula. So for rectangular is 1/, I mean this is to find the x, equal to 1/2 times the distance here. So for rectangle, because the rectangle is shaped like this. Okay, for rectangular is 1/2 because when you have forces, it will be at the center here, so that's why it's 1/2. So for triangle, because the shape of the triangle is like this, so the position of the forces would be here, which is 1/3 of the total length of the triangle. Okay, so that's why is for the triangle is 1/3 times d. But if the triangle is positioned like this, okay, then the forces would be around here. The last 1/3 of the triangle distance. So this should be 2/3 d. So this is the formula because of the position where the force is concentrated. For the rectangular is at the center, so it will be 1/2. For this kind of triangle, it's the first 1/3, and for this kind of triangle is the first 2/3 here, so it's 2/3. Are we clear? So this is actually the first. Okay. This is how to find the distance when the force is at the center, or this is how we find the distance when the force is at the first 1/3, or when the force is at the first 2/3. So it depends on the position of the force. Usually it like this. Okay, so this is actually how we, so we already get this is the answer for the resultant force, and this is the answer for the moment. So do you guys have any questions? Okay, and I forgot to point out, for this one is the distance for x3, right? Why I add, because this formula only to find for this area. This is the formula. This is only for this distance. Here, this distance. Because this moment acting at point O, so I have to add the distance from here until to the point O. So that's why I plus 1.5 plus 0.75. If there is no distance between the shape and also the point, you guys don't need to add anything. This is the absolute formula for this one. Okay, if you guys okay with questions number 3, we can proceed with the last questions. Okay. So for the last question, it's actually quite similar with number 3. So you guys can use the same concept where okay, determine the magnitude of the equivalent resultant location. So that means we will have once the value of the x, or which means what's the distance of the resultants of the moment. Okay, so in this case you guys can use the same step, which is you guys have to find the FR first. To find FR, you guys have to break down the forces, and then from there you guys can find the distance for each forces, and then you guys can find the moment around the point O. So when you guys follow these steps, you guys can solve for the unknown XR. So take 5 minutes to solve this problem. We will discuss this after 5 minutes. Okay, so since we don't have much time, so I will start discussing for questions number 4. So, okay, so basically, we have to find the magnitude of the moment and also at the measure from point O. So this is actually quite different from the previously, because the previously the point is at the very end, but this one is at the center. Okay, so before we proceed with magnitude of the moment, we find the resultant forces first. So for this one, you guys can separate the shape of the distribution. So in this case, this would be 50, this one is 30. So for the force F1 here is equal to 30 times 1.5 is equal to 45 Newton. And then you guys have to find the second area. The second force would be 50, because here is 50 for this one, and times with 0.5, because this is the distance, the length, the width. Okay, so this is equal to 25 Newton. So the resultant force would be, you just sum up these the two forces together. It will be 55 Newton plus 25 Newton equal to 70 Newton. Are we clear up until here? So if you guys not clear, you guys can stop me. Okay. Okay. So what actually the questions one is actually, okay, we already know the resultant force is 70 Newton. So if we redraw the diagram to make it only only resultant force without the individual forces. After we sum it, it should be something like this. So what the questions want is actually, I assume the forces to be on the right side of the point O, so that it will make clockwise. It's just as assumption. So if at the end your answer is negative, then that means your assumption is in the opposite direction. It should be. Okay. So what the question want is actually here. The distance of the resultant force to the point O. So this actually what the questions wants. So how we can find the value of x area? As you know, the first diagram here is actually equal to the second diagram here. So if you guys can find the moment of the first diagram, then you guys can equal the moment to the second diagram. So for example, before we can do that, you guys have to find the x value here, x1 and x2. Okay, because why I make it the distance from the point O, because it's mentioned in the questions. It's not from point A, so it's from point O. The distance should be from point O. Okay. So x1 equal to 1/2. 1.5 to 0.5 meter x2 is equal to 1/2 times 0.5. Plus 1. It's actually, this is x1 from point A. Sorry. To A. This is from point A actually. To 1.75 meter. So that means this is actually this is from point A. 0.75, and then here is actually 1.75. Okay. So we set up the moment for the first diagram first. So I assume it's like this. Clockwise positive. Moment at point O. First diagram. Is equal to Ft. Okay. So the first force is 45. And you guys have to time the distance. The distance is actually x1 here. Maybe I should give different name. say this is x3 and x4. So this is x3. Okay, so to find the distance of the f1 to the point O is actually, you know, from point O here until here is actually 1. So you just 1 minus 0.75. Oh, I'm sorry. I actually define the rotation to be like this way. Okay. Then minus 25 for force 2. (1.75) minus 1. So you guys get negative 7.5 Newton meter for counterclockwise. So it should be 7.5 Newton meter clockwise. Okay. So for second moment for the second diagram, FRD. So we already know the FR to be 70 Newton, and the D is actually, just now I use XR. Okay. So this is the value of the moment for the second diagram if you use the resultant force in the calculation. So since the first diagram, the forces for the first diagram and second diagram is actually equal, so you guys can just equal them up. So that would be sorry, this should be, I assume the force to be on the right side here. So the rotation is anti-clockwise. So the direction of the resultant force, if I will assume it to be here, it will be clockwise. So that's why it's negative. Okay, so if you equal them up, 75. So you will get XR actually equal to 0.107 meter. So this is actually the final answer. So the distance from the distance of the force for the point O is actually 0.107 meter. Are you guys clear? You guys have any questions? So if you guys can, since we already have 5 minutes left, you guys can ask questions. If not, if you guys have any question after this, when you guys go through the, when you guys go through the tutorial, then you guys can leave the questions in the chat. So far, do you guys follow here? So I will brief for questions number 14. So if I'm going to explain briefly for questions number 4. So basically, this is actually what the questions number 4 wants. So to find this, you guys have to use these equations. So when you guys use the equation, this is what you guys get. So with this value alone, you cannot solve the value of XR. So you guys have to have another equivalent sum of forces, a sum of moment, so that you guys can compare them together, compare these two values together. So basically, we need to solve for the individual forces also. So that's why we break down the that's why we find the individual forces. F1 is 45, F2 is 25, and the distance that you guys need to use here is actually this one. Why we have to use this one, this distance? Because it's mentioned in the questions, measured from point O. So basically, it's the same step from the questions number 3, but you guys have to work down. You guys have to work it uh, a bit different, because at the end you guys have to compare the value. Okay. Uh, so the final answer is negative 7.5. No, the final answer is because it wants the magnitude of the equivalent resultant force locations. It wants location. So the location is actually this one, XR. So this is actually the final answer. Because it wants to us to find the locations of the resultant force. So the final answer is 0.107. But for the value of the moment about point O is correct. Is negative 7.5 counterclockwise or 7.5 clockwise. Okay. So so that's all for today. So if you guys have any questions, later you guys can just drop in the chat. I will reply. I think that's for today. So we have 1 minute left. So do you guys have any other questions?
Miss.
Yes.
Because I mean, why is 45 or just now the slide?
Which 45?
Just now the slide, Miss.
Wait. Sorry, why I cannot share this? Do you guys can see the slide?
No, Miss.
I don't know why it suddenly unshare my slide.
But it's okay, Miss. It's okay. I will figure it out. Thank you.
Can you leave the questions in the chat? I will reply you. Can you mention which part? I will try to answer. And since it's already 12, you guys can leave for your next class.
Miss, I think no need. I figure myself. Thank you.
Okay. Okay. If then, okay. All right. Okay.
Thank you.
Thank you. You may dismiss. Okay. Thank you. Bye.